Highly esteemed colleagues, partners of all kinds, from government, from industry, from other academic institutions, from society, students, ladies and gentlemen, I would like to welcome you all very much to this Dies Natalis, the 103rd Dies Natalis of Wageningen University and Research. And this is a very special Dies Natalis, because it's for the first time since World War II that we have a Dies Natalis without the physical presence of a major audience. And it's also for the first time that we have a Dies Natalis with the Rector Magnificus without wearing his gown and his chain. We all know why that is the case. It was almost exactly 1 year ago, in 12th of March 2020, that the government suddenly announced a lockdown of all kinds of restaurants and bars, of all kinds of public places, but also of schools and universities. Of course, we had taken measures before, social distancing, hygienic measures, one-way walking routes, but a real lockdown came as a surprise to all. It was a wake-up call. Suddenly, as a high technological society, we were seeing ourselves in a situation where we were no longer in control. Of course, we had been in the situation before of a pandemic. Think about in history, for instance, the plague in the Middle Ages. In 1665, Isaac Newton had to leave his Trinity College in Cambridge, in the London area, due to the Great Plague in the London area. And he spent 1 year in social distance, we would say now, in the rural areas. By the way, that was a very productive year for him. But also later, we have seen major pandemics, SARS, for instance, or Ebola. We also know that we are still ill-prepared. This pandemic, COVID-19, came as a surprise. And we also know, by the same token, that we will see in the future an increased sequence of new pandemics or threats of new pandemics due to globalization, for instance, or the way we live with our animals, major urbanization, climate change, all kinds of factors which will increase the sequence of pandemics most likely. Over the past year, we have to try to cope with COVID-19. We've done that by assessing the major risks of social effects, health effects, economic effects, mental effects, and try to mitigate them also, especially, of course, lately by developing vaccines and a major vaccination program which we are now rolling out throughout society. Still, the past year really felt as living in a living lab, or living in what others would call real-world experiments. Because we were really experimenting in how to cope with this pandemic. And in coping with the pandemic, science played a major role. Let me make 3 observations on the role of science in the current pandemic. First, we saw that really the pandemic and the role of science in that changed the role, how we look at science. Science increased its legitimacy tremendously, and also the trust in science increased very much. We see that, for instance, in the role of science and scientists in the outbreak management team, and the way the outbreak management team advises, by scientific evidence, the government. Second main observation on science is that we see that the major acceptance of uncertainties has increased also. Acceptance by the wider public, but also by politicians. Think about, for instance, the curfew, how it was announced and how it could not really be predicted what the effects were of the curfew. So a major uncertainty, but was still accepted, both by politicians and also by society writ large. A third observation is also that science communication has increased, but also professionalized. In the major news broadcastings, we see increasingly scientists being present, rather than major media figures or politicians. Today, at the current Dies Natalis, we want to focus on the role of science in coping with a pandemic. Not only COVID-19, but especially also the threat of future pandemics. What role can it play in preventing pandemics, or in predicting them, or if not, preparing better for future pandemics? What do we know already scientifically, and what are the questions which are still out there? What kind of research do we need? It are these kind of questions which play a central role in the current Dies Natalis.
Good afternoon, and thank you, Arthur Mol, Rector Magnificus, for the opening of the 103rd Dies Natalis. My name is Marcia Luiten, and I'm your host for this afternoon. And together with our guests, we will discuss the major task for scientists in pandemic prevention, prediction, and preparedness. At my table, I'd like to welcome Henk Bekedam, former chief of World Health Organization in China and India, Marion Koopmans, professor in virology at Erasmus University, Emilie de Vet, professor and chair on consumption and healthy lifestyles, and Wim van der Poel, research leader on emerging and zoonotic viruses. Welcome to all of you. So we have the honor to discuss pandemic prevention, prediction, and preparedness with world-leading scientists. But first, I'd like to give the floor to a young and upcoming talent, environmental historian Daniel Gallardo Albaran. He obtained a doctoral degree in economics from the University of Groningen, where he studied the evolution of health, well-being, and inequality in a historical perspective. In 2019, Daniel joined the Rural and Environmental History Group at this university as a postdoctoral researcher. Currently, he's conducting a project on global health inequality, epidemics, and the diffusion of sanitation since 1850.
The COVID-19 pandemic has shown the far-reaching challenge that infectious diseases pose for a globalized world. Governments are struggling to control the epidemic by making hard decisions about the economy, healthcare, and individual freedoms. From a historical perspective, these challenges are not new. In fact, we have been here before. Take a look at the picture on the screen and see the concern in people's faces as they were forced out of their houses for disinfection purposes. This happened during a plague epidemic in Portugal more than a century ago. At that time, the expansion of railways and steamships made the world smaller. People could travel anywhere. But for this, we have to pay a price because viruses also traveled with us. This connection between globalization and disease became evident around 1900 during the third plague pandemic. This illness caused panic everywhere because it could kill about 50% of those infected. Also, there were no effective methods of treatment or prevention. In one of my projects, we are reconstructing the weekly diffusion of plague for dozens of cities to understand how diseases travel with people. As the map shows, Hong Kong experienced an outbreak in 1894 when infected rats passed the disease to humans via fleas. 2 years later, plague reached Bombay through trade, and from there it spread to the whole world just by 1900. As with COVID, trade hubs and migration routes played a key role spreading the pandemic. Quarantines, disease reporting, and quick action were crucial, but often government policies went beyond stopping the epidemic. Consider the case of Chinatown in San Francisco, which was quarantined using a barbaric method with barbed wire fences. Clearly, the official discourse of disease containment did mask inequality and discrimination towards the Chinese, who had little political voice. Eventually, the plague pandemic was conquered and then forgotten. The aim of my research is to recover our collective memory of epidemics, to enrich public health discussions with lessons from history. For instance, the case of plague shows that globalization has a flip side and that we should be prepared for future health crises. Also, access to health infrastructures should be equal for everyone to avoid any type of discriminatory policies that end up hurting the most vulnerable. This was essential to respond and build resilience during epidemics in the past, and it continues to be indispensable nowadays. Thank you.
Thank you, Daniel. Henk Bekerdam, you've been listening. Danielle said the challenges are not new, but we forgot the lessons we learned from previous pandemics. As a WHO chief, you were at the front line of the SARS virus in China, recent history. What was an important lesson you learned there in handling the virus outbreak?
Thank you, Masha, and thank you, Daniel. I think one of the most important part is about pandemics that you learn from it. First of all, it is something from, if you have a novel virus, it is sailing while building the ship, because that's very clear. You have a new virus and then you start discovering things. That's already something in itself. But it's also important that you not only learn from things, but that you also do things better. I feel very proud actually about, if I look at the Asian countries, those who have experienced SARS, they were better dealing with the SARS, with the COVID right now, and they are still better dealing. And how did they do it? They started also acting. They started strengthening their surveillance system, the monitoring system, and the early warning system. They started developing an information system in which information could be shared, an integrated information system. And they started on something else that is very important. They started building capacities. That if there would be a pandemic, that they would have the capacities to follow up with things like test, trace, isolate patients, and putting patients in quarantine.
So, and that is obviously something we were lacking, this preparedness. Huh? Is there anybody at the table who has a question for Danielle?
Yes, thank you for a very interesting pitch. So there, throughout the history that you show, the time of travel has really decreased, which really has an impact on, can you travel within an incubation period? Can we somehow bring that back? So can we use that kind of information in our redesign of what we should be looking for in the future?
Yes, I think so. That is a critical element, and it was a critical element back then. Actually, the improvements in maritime trade really, really connected different disease environments and different countries. And this is, in a way, a blessing because it allows us to interact with people in the whole world. But it can be a challenge when a health crisis take place in a country, and then within the incubation period, that person which comes from the, let's say, from the area that has suffered the crisis reaches an untouched population. This is definitely something that basically explains why plague became pandemic in 1900. And I think this should tell us that this, that the benefits of globalization, while for most people are very good, it also comes, with a different, darker, perhaps more problematic side that we should take into account in order to, build up resilience for future health crises. Because definitely, traveling times are getting shorter and shorter.
Okay, thank you, Danielle Albargaran. While we're still dealing now with COVID-19, new viruses are upcoming, and the question is not if, but when we will face the outbreak of a new virus. With our guests, we will discuss how we can handle the next virus in a better way. And our question is, what is the role of science in the prevention of a pandemic? Because we live in a world where there are more people than ever, more livestock than ever. Many of us like to travel, as you just mentioned. Wim, you're an expert on zoonosis. Have we created an environment that is favorable to zoonosis?
Yes, I think we have more or less created an environment where there is an increasing risk of zoonosis. When you look at the world map and when you look at the number of emerging zoonotic viruses over the world, there are certainly hotspots of zoonosis. And these hotspots are often areas where a lot of people live together in high density, also close to animals, often livestock, but also wildlife, where people are more encroaching into their environment. And that means that there are more regular contacts of people with specific species, and that means that there is a higher risk of emergence of zoonosis.
Yeah, Marianne, if it comes to the amount of people and amount of livestock living together on a very small area, is the Netherlands then a hotspot for zoonosis?
Well, it's one of the areas which is at risk certainly of expansion, but also well, maybe of true emergence. We've seen that with the Schmallenberg virus epidemic, epizootic, a big veterinary disease outbreak which had never before been seen, that started on the border of Germany and the Netherlands.
And when was that?
When was that?
It was in 2011. Oh. But I think that there was also a large role there for the invasion of new vectors that brought the virus to the Netherlands. And that has to do, that's also a very important issue in emergence of zoonotic viruses, that we have vectors that come more up north due to the global warming.
Exactly.
And these kinds of examples is what we use. I mean, from the medical side, I teach about them and say, okay, we were lucky this was not a zoonotic, that this disease did not have a zoonotic component, because there was a massive epidemic. And I've always called it the Zika of cattle. But it really illustrates that across the world, there's no escape. We really have to think about this. It's not a far away, distant problem. It's something in our backyard as well.
Yeah, it's obvious that there was a slow response in public health institutions with respect to COVID, especially in those areas in the world that had not suffered from SARS. Do you feel scientists were sufficiently prepared for the current pandemic?
Well, what is prepared? I think in some elements, yes, in some elements, no. If I look at the big successes, of course, the mRNA or the vaccines, which would not have been there if there had not been massive investments in that type of research, if we didn't know which components of the virus are immunogenic, how to make these vaccines. So that's, I think, a big success. The same clinical trial networks in humans. For the first time well, I think probably in history that so many clinical trials were done, brought to conclusion because of international collaboration. So that works, and that was prepared, like you mentioned, the situation in Asia. And other elements, we are looking now at a problem with variants popping up that behave differently, that spread faster. The information comes from epidemiology, from looking at the virus genomes, and virology is saying, hey, hang on, but we need to test this, but that will take months, and that's too slow. So we have to rethink how we do that kind of virology as well.
But there are good developments also, because compared to the SARS outbreak in 2003, we were much faster. Well, the Chinese were much faster in detecting the virus and characterizing it. Yeah. And sharing it also with the world.
The COVID-19, you mean?
COVID-19, yeah. Well, there is still improvement to make, but the new tools that we use and are now already developing also for detecting the variants much faster than we did before. So there are very good developments, and we certainly have to work on that to even improve them and to think how to use them very intelligently.
And it's a similar toolbox that you use for Schmallenberg, right?
Yes.
Yeah.
Yes.
So it's, and that's
well, there's lots of improvement in making it faster.
Yeah. And viruses have also their surprises. If you compare, for instance, the SARS virus and the COVID virus, they're families. One is called one and the other called two. What you can see from the SARS virus, 2003, could only spread when people had a fever. That was easy to control, because when people have a fever, they're ill, and most of the time they're home.
And otherwise they were not susceptible.
They were not spreading. And now this virus, they started surprising us.
So the virus has changed.
The virus has changed. We have a group which remains asymptomatic, that's between the 20 to 25%. And we have people who also having no symptoms before they're getting ill, what we call pre-symptomatic. And those 2 or 3 days before, the viruses are building up and that they can spread. And these people are innocently or unknowingly, they are spreading it. And that became one of the difference. If you look at SARS, totally globally, 8,000. Now, countries have 8,000 per day.
Yeah. That's a similar parallel with smallpox. That could be eradicated because by the time people were infectious, they already were dead sick. Yeah. Same with SARS. And it's very different with this virus. But back to the science, and that you can tell if you look at where this virus binds. So looking at the receptors, the tissue distribution. So that's the kind of panels of laboratory studies that you can do very fast if a new virus pops up, saying, okay, so where does it bind? What is the tropism? What does that tell us about how this may be spreading? And that's the kind of technology that really has been developing. And I think it's really... yeah, it's exciting to bring that together.
Mm-hmm. And how do you feel scientists or science can help in prevention of a next outbreak of a new or a mutated virus?
Well, I think we really have to rethink about how we are living on this globe. Because we are living together with animals so closely, first of all, but also we have a rapidly increasing population still. And that means that there is a large demand for more and more food production, more and more animals kept.
And increasing mobility.
And that's also increasing vulnerability and also increasing contacts between animals and humans. So that means that we really have to rethink how we can change that in a way that the risk decreases.
But who or where or which scientists could pull on a string in order to influence that? Because you name like a rising world population.
It's multidisciplinary. It's a big challenge and it requires many different disciplines. That's clear. And so we are also collaborating in the Netherlands Center for One Health for that reason, saying, okay, it's no longer just about human diseases, animal diseases,
also about
environmental, wildlife diseases. It needs to be brought together.
Do you feel COVID brought like an integration of all these different disciplines? Not enough.
Not
if I look at you.
Not yet.
No, I think that's something we need to work on.
Yeah.
Yes,
exactly. But may I want to build on this one. So what you need, national coordination and a multi-sectoral approach, but you need also an international approach. Nobody is an island. So we're all connected. Even when you're doing very well, but your neighbor's not, then you still have a problem.
COVID proved anything, it is this.
Yeah. Absolutely. And I think COVID is not anymore at that stage. But if you think about preparedness, we are as strong as our weakest link. Mm-hmm. And that's also where international cooperation comes in. That's also where it means that whatever resources you have, whatever knowledge you have, you need to share.
Yeah, but if you say so, I immediately think about vaccination strategies and the battle for vaccines. Do you feel this lesson is being integrated right now?
Well, there is some change. If I look we were discussing the test development. It took a while to get enough diagnostic testing up and running for people to have access to testing, and that was a fight for reagents, every country on their own, which makes no sense, because if you have no testing capacity in parts of the world, then you don't know what's going on. With the vaccines, at least in Europe and with the WHO, there was an attempt to coordinate who buys, who gets access, and how do you make sure that some of the purchasing power of the rich countries also is used for buying vaccines for countries that cannot afford it. So, and those are things, and also rethinking cost. We may think a vaccine $30 or euros is cheap. That's not, if you look at the global picture. So rethinking ways of producing things in a very much cheaper way, simpler way, but still, of course, effective.
That needs also something else. This is also where governments have to come in. This you can't leave to the markets, because if we think about something in the future, what is not yet there, the markets can't respond. So there you need investments. And like with the COVAX initiative that globally that's helped with not only buying vaccines, but also in an equitable way trying to share it, that is very much needed. But then governments need to be upfront ready to do so. One of the successes why we have made some progress with all the viruses is that governments this time, even though they were not yet clear if the vaccines would be working, but money was put on the table. Mm-hmm. And that was at least a very good balance to look from that risk we can also not put to the private sector. Mm-hmm. But we need also then then to be able to negotiate a price.
Yeah, so what you describe is how COVID actually changed the playing field. So it called for strong institutions, for scientists having a lot of authority, the state coming in. Let's have a look finally at this university, Wageningen University and Research. What can this university specifically do in order to help prediction and prevention?
Well, this university really works in the agri-food domain. So that means, and I already explained that a lot of livestock farming has to do with food production. So when we really look at how we are doing that, there are lots of ways where we can improve the resilience of the animals. We can improve the way we are keeping them. We can improve welfare of animals. We can improve housing of animals and all that kind of stuff. And also, we can do much more on prevention of introduction of viruses in livestock. And also,
you say the way we keep our livestock, we and everybody else in the world, is already an important thing in preventing viruses to spread.
Yes. Yeah. I think we have to make those production systems more sustainable. And what we are really trying to do also in this university is to create circular economy where emissions from livestock are not simply going into the environment, but are made circular, so there is not much going out of the farming like emissions like CO2 or nitrogen, and also the risk of zoonosis can be decreased by improving hygiene in farming and by changing the context with wildlife and all that kind of stuff.
Okay, thank you. Well, that is at least a very concrete thing that for this university to focus on. We've got to leave this now at this, but we'll continue our discussion later. It is at least plenty food for thought. And in our second half hour, we will talk about the relation between virus outbreaks, human lifestyle, and health. But first, we're going to enjoy the sounds of jazz trumpetist Erik Vloeimans. And it isn't the first time Vloeimans performs on the celebration of the Dies Natalis. In 2018, he and his ensemble stood on the stage of a full Weierzaal in this building. Today, there's a large audience at distance, but that won't stop the music. The floor is to Erik Vloeimans and his ensemble. Thank you, Jeroen van Vliet, Jasper Somsen, and Erik Vloeimans for this beautiful velvet sound. Meanwhile, Tessie Hick joined us on stage. Tessie developed a great interest in virology while studying biotechnology at Wageningen University and Research. After graduating, she stayed to join the Laboratory of Virology as a PhD candidate. She studies the environmental safety of self-replicating RNA vaccines. Her research can help develop a vaccine technology in which viruses are used to fight future virus outbreaks.
Have you ever thought of viruses as a useful tool? Perhaps not, as they carry so much negative connotation, especially now in the current COVID-19 pandemic. But what if I tell you that there are viruses which we can use as a vaccine tool to fight future virus outbreaks? My personal favorite group of useful viruses is the group of alpha viruses. We can use part of the genome to improve the current RNA vaccines which protect against COVID-19. These current RNA vaccines contain a fragment of RNA which is comparable to DNA. This fragment of RNA encodes for one of the coronavirus surface proteins, the so-called spikes. Upon vaccination, the RNA instructs the cell to produce these spikes, which will trigger a protective immune response in our body. We can enhance this protective immune response by adding the self-replicating genes of an alpha virus. During vaccination, the self-replicating alpha virus gene will copy its own RNA and thereby produces more spikes. This will induce a more natural and stronger immune response, even in one shot of a lower vaccine dose. Thereby, this vaccine could enable faster vaccination of the population. But is it safe to use viruses to fight viruses? Well, this technology is safe by design, as the self-replicating alpha virus RNA cannot spread from one cell to another as a wild-type alpha virus would do. These wild-type alpha viruses also encode for structural genes, which form virus particles, the vehicles for transportation from a viral RNA from one cell to another. Since the self-replicating alpha virus RNA does not encode for these structural genes, it cannot spread any further than the first cell it enters. Despite this safe by design technology, we wonder if the self-replicating alpha virus RNA can reverse into a spreading virus by recombining with a hydrologous wild-type alpha virus. So can the self-replicating alpha virus RNA mingle with a cousin from nature and form a new alpha virus? In my current research, I studied the incidence of RNA recombination between self-replicating alpha virus RNA and wild-type alpha viruses. If I detect a recombinant virus, I will evaluate how I can improve the system to make it even a safer vaccine application. Thereby, this research contributes to the development of a safe and efficient vaccine tool in which we use viruses to fight future virus outbreaks.
Thank you, Tessie. Marianne, you've been listening, you're a virologist.
Yes.
Do you feel that these self-replicating viruses are an important tool in preventing future outbreaks?
Yes, so vector technology and anything that really improves the expression of the parts of the virus that you really would like to immunize against is really, I think it's cool. I do have a question though. I mean, how are you, because I expect that we will need repeated vaccination over the years. How are you going to overcome vector immunity?
That's a very good question, yes.
Thank you.
So several papers have shown that for this type of vaccine with the alpha viruses, that's not a problem if we use the vector for the vaccine packaged in a nanoparticle. But it's a very good question to also further study if we can do this for several times, and not only for a booster vaccine, but also years later again, yeah.
Wim van der Poel, what is the potential of this technology?
Yeah, I think you can. Well, I would assume that it should be possible to get good protection. But I wondered, in your research, how can you be sure that you detect all the recombinants? Because you want to know if there are recombinants and if these recombinants are safe. So how can you be sure you detect all of them?
We cannot be sure, no. So we try to detect recombinants by this detection assay, and then we detect the recombinants which we expect. But of course, it's also interesting if we can detect different kinds of recombinants. And for that, we could use next-gen sequencing approaches, for example. But that will be a next step in this research. Yeah.
Okay, thank you.
Thank you, Tessie Hick, and good luck with this important research. With our experts at the table, I would like to talk about a healthy or not so healthy lifestyle and how that affects the pandemic. So how can science help a society to be more resilient and less vulnerable to a virus outbreak? Emily, you've been there being silent so far. You are a professor in consumption and healthy lifestyles, I should say it right. Yeah. To what degree does lifestyle now affect one's vulnerability or resilience towards viruses?
Yeah, I think it's important to realize that before the COVID-19 outbreak, the pandemic took place, we already had to deal with a health crisis, and that had to do with lifestyle-related diseases. So in the Netherlands, many people, and not only in the Netherlands, but in most Western countries, many people suffer from obesity, diabetes, cardiovascular diseases, and those suffering from those diseases increases the risk of a severe outcome of COVID-19 infection. Those diseases in itself are largely lifestyle related.
And so with another lifestyle, you would erase these chronic diseases for a large part. Yeah,
and with another lifestyle, I think we can prevent that many people develop these chronic diseases, but also prevent that once a pandemic takes place, that it has such severe consequences in society, and leading to such a detrimental health outcome.
And do you feel that policymakers or politicians are open to this message that actually public health is a crucial matter and lifestyle sciences in that respect as well?
Yeah, I think they become more open to this message. And I think that COVID-19 also, brings it a bit more to the forefront that we already had a health crisis. I still think that there are major steps to be taken, both in terms of how to advance our knowledge on promoting healthy lifestyles, as well as on implementing those insights. There are some insights in how to change behavior, but that doesn't always result in the right policies taking place. And on the other hand, we still need a better understanding of how we can shift lifestyles in a way that those novel lifestyles are sustained over time and can really contribute to prevention and health promotion.
Do you agree, Henk, that COVID was a wake-up call in this respect?
Actually, it's re-emphasized the issue what we already knew, that we have a crisis on board with non-communicable diseases, but also something else. And I think sometimes when you look at the money, it gives you a picture. The Netherlands, we have a very good system. More than 10% of the GDP is being spent on health, and that's good. That's better. The Dutch are in somewhere in the middle in the EU.
But is it spent in the right way? If you look
yes, now there you come. But if you look from what has been spent on public health, that is only 0.5%. I think the balance is lost. And I do think that we need to do some rethinking. And that's also a little bit linked to something else, what you have seen in the Dutch system, but also perhaps in Europe in general. If you let play the market a bigger role in the health care, then there are two areas where it doesn't fit so well, the market. And one of them about safety, the things that we were talking about, that you have a good surveillance system in place and that you start investing in things what might be coming, all the discussion what we just had about the new pandemic.
For the market logic, that is only a cost.
No, they don't even see it. It's not yet there. And
prevention is very difficult to measure.
And second, and prevention, for instance, and that's the other point, where the market can't see, it is not good. It's not working. So this is something where the government needs to take a leading role. So those percentages needs to come by a very clear push by the government to start investing in prevention. And that's not only important for COVID, that's important for all of us now.
But for years ago, we've reorganized our health system where the market logic is leading.
Yeah.
So you're saying the system that we have is not able or is not good enough for virus prevention.
Now let me also, I'm not a basher of the market because many things have done also quite well. I think we have a very efficient system. But an efficient system might not be good enough when, for instance, when you have COVID, then you need a little bit of a buffer. We've become so lean that perhaps we should have a little bit more beds.
We've cut out all redundancy.
All redundancy are there. And I'm not saying that you can ever prepare yourself properly for a pandemic, because that's always one, but you need to have a little bit more capacity to do things. And it's including also start investing in public health.
Exactly. Because public health is not valued by the market, Emily.
No, I agree that we need to invest much more in public health, and also that we need to shift our thinking on public health.
In what
because
way?
if we think about, for instance, non-communicable diseases like obesity, the focus is very strongly on focusing on high-risk groups or supporting weight loss, say combined lifestyle interventions that take place in care, and then there are still healthcare interventions. While if you would want to shift, say, the average level of population health in healthier directions, so really health promotion, then you need to focus on a much wider group in society. You need to focus on, for instance, improving socioeconomic conditions, making sure that you reduce the health disparities that are currently really large in the Netherlands, that we create a living environment that makes it healthy, or that makes it easy to make healthy choices, and that invites to engage in physical activity, for instance. So the type of measures that are needed to promote health are different ones than currently being invested in.
On these disparities you mentioned between lower and higher income groups, I think, is income the only relevant factor?
Now, it's a combination. It's a lower socioeconomic position, and that comes with a complexity of consequences. So it means a lower income, it means a lower education, but it also means that you have less means to afford housing in an area where you have a lot of green space, for instance, where you can exercise. Say the density of population density in those areas is higher,
much higher,
making it also easier for a virus to spread in those in those poor families. I would say.
And is science prepared to help governments and policymakers on this issue, or is there also a lot to do in science and research itself?
Yeah, but I think it's a little bit sad. The science on that non-communicable diseases are an issue, and that lifestyles are making a big difference. It has been with us for years. Look at tobacco. It kills. And why are we so slow?
But isn't that about behavioral change science? I mean, that's been one of the key conclusions of the pandemic as well. How do you, we know what to do,
but how to shift
what
behavior?
Does it take
and I would say there is a lot of knowledge already there, and smoking cessation is a clear case where a lot of measures have been taking place, and it has become clear from smoking cessation that you need this large variety of measures and really a long-term investment to make sure that smoking prevalence reduces. It's still not optimal, of course, but for many other lifestyle-related factors, we aren't at that stage yet, and there's still a lot of knowledge also at the behavioral science. I would say that we need to gain, that it's not out there yet.
And how can science help create a favorable environment for these behavioral changes?
I think what is important is that we, first of all, invest in behavioral science, because it's
there's many little now.
Yeah, I think so, and I think that many of the investments and the emphasis on science is on say more the technology-driven, and the life science technology also a bit medicine focused, while if I reflect back on the pandemic, you see that we can make major advancements in science, in vaccine development, in all kinds of strategies, but changing people's behaviors and making sure that people adhere to guidelines, to corona measures, that's a lot more difficult.
Let's see what the other side thinks of that. Yeah.
Can I say, because I fully agree, but I also see that those worlds are siloed, and it's really difficult to bring them together because the cultures are so different. The work, so I'm interested to hear how you would approach that.
Yeah, I agree that those worlds seem silos, but I think that, and that is also Wageningen University, I think, and research is a place where you can combine both worlds, where we have social and behavioral sciences present within. Of course, it's still siloed in the social sciences, but can be connected to all the different life science groups, whether it's food sciences, plant sciences, or animal sciences.
You say can be, but is it?
I think that can be improved, definitely. But it's.
And if we look at the total amount of resources, let's say that amount of resources available for science will not change. Wim, do you feel that there should be more money being distributed to the behavioral sciences and then at the expense of the hard science virus research?
I think the most important thing is that we really involve social sciences in the hard sciences also. So work together to not only develop the technology, but also develop the behavior that is needed to use the technology in the right way. Yeah. And also to think about what affects our health and behave better to live healthier.
Okay.
But there is also a role for the politics, for the authorities to create an environment where people are more looking at their health and there is more incentive to change your health, to change your behavior, to live healthier.
So would you be in favor of like a sugar tax and these kind of?
Actions like that could help. I don't really know about sugar tax, but I think there is a role for the government.
These also, kind of incentives
for the politics.
May I build on the things that we're just discussing? What's also very important from science is how can science get into policy? That translation is important.
So where does that block?
Now, so then you need to connect. And you need to make sure that you also come up with something what can be done. But also, I think politicians need also to be held responsible for things. The way we dealt with the tobacco industry, I think it's a shame. How can we so long still engage with an industry which actually is producing a product what kills?
But it's so harmful.
But it's so harmful. So we need also to look at that component. But what's also very important, like you said, sometimes the market can also help to get to a healthier path. With tobacco, we knew, make it more expensive, and it's for younger people more difficult to engage. Now, look at the sugar tax. Perhaps we can also do a very positive tax. Why don't we make healthier food cheaper? And I think these things, sometimes the markets can also help with getting ourselves healthier.
Oh, I'm so sorry. We've got to leave this discussion right now because time is running out. And I wanted to know from the four of you, actually, discussing these things, virus prediction, prevention, what do scientists need in order to be better prepared for the future? Marion?
Systematic funding.
Systematic funding.
For the collaborative science.
Okay, that's the...
So we all have individual funding schemes. We really need...
Integration.
Bring it together, put a dot at the horizon, get it on.
Good, clear. Wim?
Yes, involving social sciences but also environmental sciences to work together. Well, I think all health-related scientific disciplines should work together, and I think more resources would certainly help for that.
Okay, Emily, what would you need?
A long-term vision, because I think these problems can be dealt in the typical 4-year trajectories that we get funding for. It really requires a long-term investment.
Okay, clear. And Henk?
I think investing in health is not a cost. Investing in health is investing in our future, is investing in the health of the people. So we need to get the resources also to make it happen.
Yeah.
And also I think here again, look at the market part again, we need to make sure that we get the benefits from the market, but that we also clear from where the market at a certain moment cannot do their work, that the government has to come in with a sufficient funding to make the good things happen.
On a long-term perspective, enough funding. Thank you very much, Emily de Vet, Henk Bekendam, Marion Koopmans and Wim van der Poel, because we're at the end of this table discussion. Thank you very much. Of course, thank you, Danielle Gallardo-Albaran and Tessie Hicks. Thanks for your excellent pitches. And we're near the end of our program, and I'm going to give back the word now to Rector Magnificus Arthur Mol.
Thank you very much, Marcia. Those of you who've been earlier at one of our Dies Natalis know that we always hand out a major research award to a young scientist which has published the best research paper. So let's move to the chair of the jury, Professor Alfons Oude-Lansing, to inform us which major scientist has this year received this award.
We had quite a few very good submissions, and we had a lot of discussion about the quality of the different submissions, but we also all agreed that this submission stood out in terms of its quality, in terms of the contribution to the consortium, in terms of its clarity also. So this was actually for us also a unanimous decision.
Well, we discovered a new way of fixing CO2, capturing CO2 from the air through microbes. No? So these microbes can take the CO2 and produce organic compounds.
What was very special about this paper is this is a very good example of hypothesis-driven research, and I think it was also very special that this paper actually was very clearly written, also in such a way that it was understandable for the multidisciplinary team of researchers that did the evaluation.
Well, it means a lot because, of course, it's very nice to have the recognition for hard work in general, but also in this case it was a very special paper because it meant more than 3 years of laboratory work. Also, integration of many disciplines and many collaborators that were just not co-authors but also friends. On a more personal note, I couldn't really celebrate the publication of this paper due to personal circumstances, and this award has also now allowed me to revive that moment and being able to finally celebrate it.
A great winner we have for this year. Well, ladies and gentlemen, we come almost to the close of this Dies Natalis, the 103rd. Having heard all the challenges we are facing with the current pandemic, but especially with future pandemic, you might wonder, what is Wageningen University Research going to do about that? What type of research are they planning? Let's move for that to Ludo Hellebrekers, who is the director of Wageningen Bioveterinary Research. Ludo, inform us about this.
Here at Wageningen Bioveterinary Research in Lelystad, we do research on infectious diseases. Primarily infectious diseases in animals, but when these pathogens jump to humans, we investigate the zoonosis as well. With the ERASE program, Wageningen University and Research will contribute to the scientific foundation of what policymakers, decision makers and society need to try and prevent the next pandemic from occurring, or at least help and prevent the catastrophic effects as occurred with the present pandemic. ERASE stands for Early Recognition and Rapid Action in Zoonotic Emergencies. Together with many collaborators, both nationally and internationally, we will work at developing new knowledge and methods in order to prevent, recognize and combat new zoonotic emergencies in an early stage. Think of accurate pinpointing of hotspots areas in the world where the next zoonotic emergence may occur. And think of developing smarter and more effective early warning systems and designing vaccine platforms that can help design, develop and adapt new vaccines for upcoming infectious diseases. We will take an interdisciplinary and collaborative approach from a One Health perspective. That means that we will consider the interplay between the health and resilience of man, animals and ecosystems. Together with our partners, we can make optimal use of the insights we're gathering today to be ready to answer the challenges of tomorrow.
What surprised me most as a Rector Magnificus and us as an executive board of this organization is that during this disturbing pandemic, we continued at our organizations to do excellent research and excellent education. Not in a business as usual way, but adjusted and fine-tuned to the new context and the new situation. So in closing this Dies Natalis, I want to thank and express my gratitude also to all our staff, to our teachers, to our researchers, to our supporting staff, but especially also to our students for their commitment and major effort in coping during the pandemic with all their work, education as well as research. And with that, I hope to see you next year with our 104th Dies Natalis, and then hopefully, of course, in a normal situation where we can also live with the real excitement of a Dies Natalis, having social interaction before, during and after the Dies. Thank you for staying with us. See you next year.